for us. Over to you, Marie.
Kia koto. Hope you've enjoyed the morning so far, and I think this session is probably maybe a little bit lighter, not so much heavy thinking involved, but hopefully you'll go away with some fresh ideas to implement maths games and number sense routines into your own classroom. So we'll get started straight away. It's a real privilege to be part of this AMA online, so let's have some fun together. Playing maths games when we're virtual does pose a little bit of an issue, but we'll hopefully come up with some ways to get around that. Okay, so let's get going. I think it's always really good to think of the purpose first of all, and maths games and daily number sense routines do provide another opportunity in a fun way for developing fluency, reasoning and deeper understanding. And just to be aware that when I say fluency, I'm not meaning speed. I'm taking away the speed equation. When I'm saying fluency, I'm meaning it requires very little thinking as you're thinking about questions. It's an automaticity. So in our workshop, what we're going to have a look at is a range of activities to highlight certain features around games. And we're going to be thinking about what makes a maths good game or a number routine, and also how you can adapt activities to suit either different needs or year levels in your school. Or different formats. Okay, so I'm going to start with a number sense routine warm-up. This is a really nice one. It's if this is the answer, what could the question be? So what in this example, if our answer is 12, what I'd like you to do in the chat, please, is put down an equation or a question as to what the question could be so that your answer would end up with the number 12. And while you're doing that, I'll just talk about this type of warm-up. Why I like it is that it allows everyone to access this problem. It has a very low entry, but it also has a very high ceiling, as it allows children to show what they can do and what they know. So it's really nice in that respect. If you're doing this in the classroom, what I suggest you do is you give the children, a couple of minutes or so to in their book to jot down as many different ways of making 12 as possible, and then maybe come back together and they share one way that they thought was most interesting. You could do the sharing on a real whiteboard, or you could use a virtual whiteboard like Jamboard, or you could use another collaborative platform, for example, like Padlet, to share your different ways. Okay, so I think you've all put lots of different questions in. So I'm not going to share all those, but I'm going to talk about the types of things that you could have been putting. For example, it could start with just very simply adding two numbers, or it could go further up thinking about multiplication. You could be using doubles, you could use fractions, decimals, and so on. This is an example of what that might have looked like. You can see how it's very low entry and high ceiling. You might want to include maybe one of those constraints as part of how they're thinking about the answer 12 as you go on, because it has an opportunity to maintain prior learning as well. So that's if this is the answer, what could the question be? Okay, so what makes a great activity a good game? And I think the first thing we need to consider is, does it engage everybody at the same time? There's nothing worse really than sitting waiting for someone else to play when you're actually not involved in any thinking yourself. So can it engage everybody at the same time? Does it focus on thinking rather than speed or luck? Those are the much better games. We want to eliminate the thing around speed, and luck is not quite as good. Does it provide the right level of challenge? Not too easy, not too hard. It's that Goldilocks principle, isn't it? It's just right to be engaging. And when you're thinking of your games, can it be adapted for other levels or other maths focuses or foci? And to do that, is it a game that's really easy to learn? Does it require lots of instructions, or is it quite simple, so therefore easy to adapt? Is it easy to prepare? I'm personally one that, we're all time poor. We don't want to have lots and lots of different equipment in order to play good games. And also a really good tip would be to have those little videos made that shows children how to play the game, so that you're not always having to give all the instructions, or they have a referral place back for that. Now, there are lots of places available where those videos are already there, so use those. Or another thought might be to get some of the older students maybe to make a video on how to play games for other students. The last thing to think about is what's the best format for the game. You can play games that are whole class and they transfer down into partner games or small group games. Those are the ones that we're looking at today. We're not looking at ones necessarily for individual activities. And then also thinking about your format, hard copy games, or do we use digital online games, or perhaps interactive Google Slides. So we're going to have a little look at a mixture today. So after today, you'll get some resources, and one of them will be this big treasure box of maths games. And I'm just going to highlight a few to talk about the pros and benefits and so on of using them. So the first one we're going to have a look at is Countdown. And I call it Countdown because I remember it from the TV program. I don't know if you're familiar with that one. So the purpose of this game is to make the target number, which in this instance is 898. And you can use it, well, you can make the target number by using any of these numbers along the top. The rules are that you don't have to use all the numbers at all. You can use them in any order, but you can only use each number once. So I've found the little countdown clock, if you're familiar with that, and put it into the slide. So we're going to have a go. This does have a timer, but obviously in your own class, you may not want the timer. So I'm going to set the timer. I hope you have a pen and paper handy, or perhaps just do it in your head. See if you can make the number 898 using any of those numbers. Are you ready? Let's set the timer. Have a go. Okay, now there's lots of ways that perhaps this could have been solved, and as a class you share those ways. This is one way. Maybe you did 50 times 2 is 100, then 100 times 9 is 900, and then we needed to make another 2 so we could take it away. So we could make the extra 2 by doing 6 take away 4. So that might have been one way that you were thinking about solving it. Now this comes from Math Starters, where they have them there ready for you to run very, very simply. They call it here the numbers game. And it just means that you don't have to make these up yourself. So you can adapt it. You can either have no large numbers and 6 small numbers, or you could pick one large number, i.e. a 25, a 50, a 75 or 100. And that will then have 5 small numbers and so on. So they're there for you. It also has an opportunity at the top for a simpler game as well. So that's the numbers game. Okay. The next one I'd like to have a look at is number boxes. So this is a very, very versatile game. You can play it for a whole different ways of whatever it is that you want to focus on. We're going to play it together first, and then we'll discuss how to adapt it. Okay. So the way that we're going to do this is I've put in here a dice. I couldn't embed a virtual dice, but I've embedded a video of a dice being rolled, so we can use that. I'm going to roll it, first of all. I'll be team 1, and you are going to be team 2 in a minute. So here's our team 1. Okay, so I've been given a 4. Now the way you play this game is I then have to choose where to place that 4. So I can either choose to put it in this first box, the second box, or the third box. Or if I don't want to use the 4 at all, I'm allowed to have 2 throwaway boxes up here. I can just discard the 4. And the aim of this game could be that you're trying to get as close to a target number as possible, or maybe you're trying to make the biggest number as possible. I'm going to try and make the biggest number possible. So where do I want to place the 4? I don't know, let's put the 4 here. Okay. All right, so I'm going to roll the dice for you now. You're going to be team 2. So again, hope you've got a pen and paper handy. Here's the dice. You've been given a 5. So have a decide where you would like to put that 5. It could be in your first box, your second box, or your last box. And remembering, You're trying to make the biggest number possible. Okay, my go. I now have a 3. I don't really want that 3. I'm going to throw it away. I'm going to put it up here in my throwaway box. Okay, your go. Let's roll the dice. You've got a 6. You're quite lucky. You've got a nice big number. Where are you going to place that? My go. I've got a 4, another 4. Okay, let me see. I'm going to put my 4 over here. So I'm going to end up with 44 times something. And now it's your go. You've got a 1. You might want to throw that one away, put it in your throwaway box. Okay, my go. I'm hoping for a 6 or a big number. A 5, that's not too bad. Okay, I'm going to put my 5 over here. And it's your go now. So you're going to try and use your numbers to beat my 44 times 5. You've got a 1. Okay, you might want to choose to throw that one away. Now, I can't have any more goes. I've completed my numbers. I can't change them now, even though I have another throwaway box. So I'm thinking about 44 times 5. Well, I could think of that as 40 times 5 and 4 times 5 and put the 2 together to get my total. And obviously, you're going to see if you can beat me. I think some of you may have an extra roll of your dice. So there's your extra roll of the dice. You've got a 4. Okay, so you can see how that game works. Now, what I like about this is that maybe at the end of the game, you could ask the students to have a think, well, if you were going to have a chance to rearrange those numbers that you chose, could you have put them in a different order to have made a bigger number? That would have been a nice follow-up activity, and it involves a little bit of investigation there. Another adaptation on that game is called Nice or Nasty. And that would mean where I haven't, when a number is rolled for me, for example, say I got a 1, I could be nasty. Instead of keeping that number for me, I'm going to make you use it somewhere. So that's just a little, another adaptation there. There are different ways you can play the game as well. As I said, we've been playing it with some 2-digit by a 1-digit multiplication. But you could also just use it for place value, where they're placing numbers in for making a bigger or a smaller number. You could use it, the similar idea, but have decimal place value, thinking about where to place those numbers. Or it could be simple addition, or obviously a bit harder addition with your different numbers of digit boxes and so on. So it's a very, very versatile game that you can use in all sorts of different ways. So that's number boxes. Okay, now I'm going to use my get my co-host to play a game with me now, Robin. So we're going to play 4 in a row. The reason I've chosen to show this game to you is that we're going to use an interactive Google slide for this game. And the advantages of having an interactive Google slide means that we can both play on the same game board together, even though we're quite far away from each other. It also means, of course, then that in your classroom you don't need as much equipment, you don't need many counters, and you don't have to disinfect all the equipment either. You're trying to keep things clean. So Robin and I are going to play a game, and the way you play 4 in a row is that you take turns to move the arrows and choose a digit at the bottom. So I'll put mine on first so you can see how to play. This is addition, 4 in a row, addition to 20. So I'm going to choose to move my blue arrow on the 4, and I'm going to put the green arrow on the 6. So 4 plus 6 is 10, and I'm going to be yellow. So I'm going to put my yellow counter on the 10. Now, my partner will then choose, in this case, Robin, is going to choose to move one of those arrows, just one of them, to another number, and then place her red counter on the board. Aim of the game is to get 4 in a row, or obviously you can try and block your partner, your opponent, making 4 in a row. So Robin, do you just want to unmute yourself, and are you able to drag your one of the arrows now, and you're going to be a red counter?
Right, well, I've got to be a little bit strategic here about where I'm going to put my dice. With so that can you go on a diagonal?
You can go horizontally, vertically, or diagonally.
Thank you. I have to shift, don't I? So I'm going to go to 7 and put my counter there.
Okay, on number 11. All right, so now it will be my turn again. So I can still try, and maybe I'm going to try and make 4 in a row this way. So can I make 16 by moving any of those? Yes, I can. I could move my 4 up to the 9. So now I can make 9 and 7 is 16. So I can now start to build my 4 in a row that way. Okay, over to you, Robin.
Right. That was a silly move on my part, wasn't it? I'm going to bring this one back to 3 because I can't put my number on your number, can I?
No.
No. So I'm going to have to go to, whoops, sorry, I shifted 2 things.
Okay, so you made it 12. Okay, so hopefully you can see how this game works. And why I like these sorts of games is that it actually really does depend on what my partner does. So it's very interactive. I can't really have a think about what I want to do until I know where my partner has gone. And just a little tip, when you're playing games, obviously this one is with a small group, not necessarily whole class, although you could split into 2 teams and display it. But my little tip for playing games is that get children working in pairs against another pair, rather than individual against an individual. It just allows the opportunity for the pair to have that discussion and the extra thinking between them, rather than always just by themselves where there's less chance for them to talk about things. So 4 in a row, you've seen this version, which is for addition to 20. But there are lots of other different versions you could have. This is just addition to 10. Or you could have multiplication, where you're practicing your multiplication facts. Or you could have addition and subtraction of decimals as well. So it's very versatile depending on what you're wanting to do with it. So that's 4 in a row using an interactive Google slide. They are quite easy to make. I have a video about this one on my website. I think it might be one on the AMA website, but easy to make. Okay, so that's number boxes and 4 in a row. The next one I wanted to have a look at was Guess My Rule. So you're going to be involved with this one. You may have seen these types of activities before. And I'll just explain what's going to happen. I've got a Misra rule in my head. And it could be either a 1-step rule, like this one here, which is just subtract 3, or it could be a 2-step rule. In this example, it's multiply by 2, then add 3. And the aim of the game is that you will guess a number, or you choose a number. For example, if you had chosen the number 3, I write it in here, and then I'm going to apply my rule and put in the outbox what that would become when I apply the rule to it. So when you put in 3, the outbox is going to look like this. When I've applied that function, it'll be 14. So what I'd like you to do in the chat, I'm going to start putting in numbers. I'm imagining people will be putting up their hands and asking a number to go into the inbox, but I'll just put those in for you. And write what would happen each time in the outbox and see if you can decide what that rule would be. And write it in the chat once you've got an idea. Okay, so imagine someone's put in 7. Okay, I'm going to apply the rule and write it into the outbox. Okay, so it would be 34. Let's do another one. Maybe someone's put their hand up and asked about 0. What will happen with that one? Quite an interesting one. There you go. What about this one where someone has put in number 4? When I apply my rule again, what's going to happen? So if you think you've got the idea, have you written it in the chat box? So my rule was to multiply by 5 and then subtract 1. Hopefully that's all right. So it's a good opportunity to apply basic facts knowledge. Is looking at relationships between numbers and getting them to think more multiplicatively in this instance, not just additively. Now, there are online digital tools that do this straight away for you. The one I want to show you is the function machine from Topmarks. It does require flash, so you might just have to allow flash if you're using it, for example. So this is what Topmark's function machine looks like. Same ideas that we were playing just before, where people choose an input. So maybe they've chosen number 4. We click the output to see what that looks like. And I'm going to store the numbers on my notepad over here. Okay. So then I'm going to put in another number, 5. Let's see what the output was. It's -2. Store the number. What do we think is happening in this one, for example? So I think it could be maybe that it's taken away 7. Shall we have a look? There it is. All right, so that's Topmark's, and you can adjust the function machine from being a 1-step to a 2-step, or in fact you can make up your own. So it's again quite versatile for practicing. So that's Guess My Rule. The other one I want to show, not necessarily for the game, because it's quite a well-known game, but for other reasons, is Skunk. It's a lovely whole class game, lots of fun. If you don't know how to play it, I'll just quickly explain. So that everyone draws up their columns, S-K-U-N-K, that means that there's going to be 5 rounds. And at the end of the 5 rounds, you add up your total, and it's, you know, you're trying to get the biggest total possible. So what happens is that you roll the dice and you add it and you write it into the first column. So let's see. If you're with younger children, you can change this one to just 1 dice rather than having to add 2 dice each time, or in fact make it harder with 3 dice. So again, a bit of versatility there. So let's just do 2 dice, roll the dice, and obviously 3 and 6 is 9, and that gets put into the S. Now what happens is that you keep rolling your dice, but each time you choose whether to bank your total, or you think, no, I'm going to stick with that, I'm going to play safe. Because if you roll a dice that has a 1 on it in this game, you are skunked, which means all the totals you got in your S column have now been taken away. You end up with 0 for your S column. So if you're playing this whole class, you usually get the children to stand up whilst they're playing, and then sit down once they want to bank their numbers. So for example, if we rolled again, another 9, we'd put that into S. You make a decision whether to carry on playing or to sit down and be safe. There we go. Oh, keep playing. We've got a 10. Keep playing. Make a decision. So that's how you keep playing. And obviously what it looks at is probability as well, involving chance. What is the chance that a 1 might come up on those dice? So we're not going to play the whole game, but I just wanted to show you that this is one of the games that's available from Transom. And they have actually a whole range of maths games that are ready just to put up and play. So if you haven't seen the Transom site, do go there and have a look. They've got lots and lots of games. One of them is Maths Words. And this one is great because you can use your warm-ups time, your maths games time, to practice maths vocabulary as well. So this is one that has easy, medium or hard words that you can display. And there's lots of different ways, again, you can play this game. It might be that you've got the person at the front who can't see the number that's being displayed. In this instance, it's circle. So maybe the person at the front can't see the word circle. They've got the back to the wall, and the rest of the class can see the word. And then it might be that the person in the front's trying to guess it by asking questions that the class have to respond yes or no to, like, am I a shape, am I a number, and see if they can guess it within maybe 10 questions. Or otherwise, the children are giving clues for that person to try and guess the word. You could flip it around so that the class are involved with more of the thinking, where in this instance, the person at the front is the only person who sees the word, and all the class have to do the thinking by asking questions and so on. So a really good opportunity to practice maths vocabulary as well. So I won't talk about bold fact. It is a favourite of mine, really good and adaptable, but I'll let you find out about that one yourself. I'm just concerned about the time to look at some other things. So those are a range of different games that you can play. So let's have a look at some number sense routines. wouldn't we all like to be somewhere sunny at the moment? So number sense routines, different from games. These are routines, daily routines, that will help students to develop fluency, reasoning, and also maths language. So it is different than games. One of the best number routines would be running a number talk. Now, I'm not going to do that in this session because this would be too small to really do that justice. So I'm going to look at some other number sense routines. So this, when you get all the resources, you'll get this collection, and you'll notice a lot of them I have taken from Steve Waborny's site, who has developed lots of lovely free math sense routines that you can be using. Things like Splat, estimation ones, cubes, they're fabulous. And if you don't know about them, it's worth having a look at what's on his site. Very simple to use. You just download the slides and you're ready to roll. I've also included some other ones here, and we're just going to highlight a couple in our session right now. So the first one I'm going to look at is one from Steve Waborny called Estimation Clipboard. And why I like this one is because it really develops the skill of estimation. I've been finding recently when I'm working with schools and with children that children are getting quite reluctant to estimate because they don't want to be wrong. So to build those skills of estimation and getting them to think about, it's not just a guess, it's a good guess. And a good question to ask is, what do we know is going to be too high? What do you know that's going to be too low, in order to get a range happening? So this is how you play Estimation Clipboard. And these are just simply slides you download from the website. So first of all, they get asked a question, and I'm going to get you to do this yourself. So how many dice are being held in the cup? Make an estimate now. And we're going to tell you how many are in that cup. It's 28 dice. So now you're going to use that as a benchmark to work out how many you think are going to be in this second cup. Make another estimate. How many do you think will be in that one, given that we know that's 28? Have you made your estimate? Here's the reveal. Okay, there were 17 in that one. Oh, we've got one more. Let's have a look. If that was 17 and the first one was 28, how many dice do you think are in that cup? So by now, the students are becoming a bit more confident, having a bit more of a benchmark about how many they think might be in that cup. Let's have a look. There we go, 33. And now we've got our final one. Here's our last one. And at this point, you might actually want them to share their estimates. You might want to get them to turn and talk to their partner, or perhaps collect them, because we've now got a few benchmarks. So let's have a look at your final estimate. If you want to put it in the chat, feel free to put it in the chat. Let's have a look. If that was 28, that was 17, that was 33. What do we think that was? Okay, did anyone get it? 22, give yourself a thumbs up if you did. So it builds those skills of estimation. It's a really lovely one, especially with our younger ones. Now, remembering estimation, we can estimate numbers, but we can estimate quantities of measurement units as well. And because it's really hard to estimate though if you don't have a benchmark. So when you are thinking about measurement, make sure they have a benchmark for measurement. So they have a benchmark for what 1 centimetre was, so that they can therefore estimate using it. Now, Steve Waborny also has another wonderful series called Esti Mystery. So we're going to play this one together. And at the end, after clue 5, I'm going to ask you to put your guess, your Esti Mystery, into the chat. So this is how you play. It starts the same, where we're trying to find out how many objects are in this cup here. But this time you're going to get some clues. So are you ready? Have an estimate, have a piece of paper, write it down somewhere. And here's your first clue. So the answer is a number less than 50. So you can revise your thinking. If you'd like to change your estimate, revise it. Here's the second clue. The answer is also an odd number. So again, have a moment if you want to revise your thinking. If you had made it even, now make it odd. Okay, the answer is a multiple of 3. So again, you might want to change your estimate. And start looking now at the language that we're using. This is a really good opportunity to build up that maths language so the children are hearing it and understanding it. Okay, clue 4, here we go. The answer includes 2 different digits. You can revise your thinking. And our final clue, are you ready? The final clue is that neither of the digits is a 2 or a 4. So you may now have narrowed down your estimate. Write it in the chat. What do you think it could be? How many objects do you think are in that glass? Now, before actually I would go to the reveal with my students, I would like to get them to explore these clues in a little bit more depth. So what I'm going to do before we go to the reveal is I'm going to take them to a hundreds chart so we can explore a little bit more about those clues. So I'm using one of these lovely ones from Toy Theatre, and I can do the highlighting as we go. So here we go. I'm going to colour in yellow the things that could be a possibility. Well, the first clue was that the number was less than 50. So I know we're looking here somewhere in the top half. The second clue was that it was odd. So let's highlight all our odd numbers. Here we go. This could be a possibility of how many objects there were in the glass. All right. Then after that, we had a clue that told us it was a multiple of 3. So let's now eliminate all the ones that aren't a multiple of 3. Good opportunity to explore those patterns in a multiplication chart, or maybe to apply multiplication rules. Okay, so let's just check I'm doing this right. I think we've got all of those ones coming on. Okay. Now then, our last clue, let's get rid of these ones, there we are, was also that it was 2 different digits. Okay, so they have to have 2 different digits. That's not these ones here then. They have 2 different digits. We can eliminate 33. And our final one is that neither digit is a 2 or a 4. Okay, so we can get rid of the 2. We can get rid of that 4 there. I think I should have got rid of 27. Oh yeah, it doesn't have a 2. There we are. All right. So we've now eliminated it down to 15 or 39. So let's have a look. We'll go to our reveal now. Which one do you think it is? Is it 15 or 39? Okay, so it was 39. Did anyone get that? So that's SD Mystery. It's a really nice one, and it brings in some lovely maths language as well as estimation. All right. One of my favorites, again, is which one doesn't belong. Oh, let's take those ones away. So I'm going to get you to do this one. So I've pulled up 4 numbers from the Which One Doesn't Belong website. And what I'd like you to do, again in chat, is to decide on which of those numbers you think doesn't belong to the set of 4, but to justify why. So, and there's no right or wrong answers. That's what's lovely about this number sense routine, that it's open-ended. It allows, again, students to bring to the discussion what they know about numbers and hopefully learn something else from hearing the thoughts from others. So put your ideas in the chat. Which number, 9, 16, 25 or 43, do you think doesn't belong? And can you justify why? What's your rationale for that? So some of the responses might include some of these ideas. Maybe 9, because the sum of the digits does not equal to 7. 1 and 6 make 7, 2 and 5 make 7, 4 and 3 make 7, but 9 doesn't add up to 7. Maybe 9 because it's the only single digit. Maybe you chose 16 because that was even and the rest were odd. Maybe you chose 43 because that was not a square number, and 9, 16 and 25 are square numbers. Or perhaps you chose 43 because the tens digit is greater than the ones digit, whereas it's not true for the other examples. Or again, maybe you chose 43 because that's the only prime number. Again, as I said, it's great for bringing a lot of other maths concepts to the discussion, open-ended. And I've highlighted in red there all of that maths language and maths understandings. Great opportunity to use, to apply, to practice using maths language. Now, if you are using which one doesn't belong, when you go to the link on the website, it will have a range of numbers that you can use already. It will have some which one doesn't belong with shapes, with 4 different shapes that you're choosing about which one doesn't belong. It does have graphs, which I find a bit harder. I think they're aimed maybe for a bit of the older children. But you can make up your own. You could maybe include symbols. You could use words and pictures linked to with a particular meaning. We've talked about shape, but you could maybe include measurements, measurement units, measurement devices, and put 4 of them together and think about which one doesn't belong. It could be fractions. So do think of the whole range. It's not just about numbers. Now, a way to then follow up this activity, which I quite like, is to take one of the examples and complete the set. So here's an example. The first one we thought about was that 9 was the odd one out because of the sum of the digits didn't add up to 7. So now perhaps we have to get the students to think, okay, if you are now going to complete the set, what number would you have put instead of the 9 to complete the set? So it's just a nice little twist. It makes the thinking go a little bit further. Okay, just a couple more to finish off with. Always, sometimes, or never. Really nice little number sense routine to start off with. And this is how it works. First of all, you provide a statement, which we'll give you in a moment, and you allow everyone some good wait time to consider that statement. And while they are waiting, they are deciding whether they think that statement is always true, sometimes true, or never true. And to do that, they have to then justify their thinking, to prove why they think it's always, sometimes, or never true. And a good idea is to include an example or a non-example to show why. And the last step then is to refine the statement, if necessary, to make it always true, sometimes true, or never true, but we want to make it always true. Okay, so let's have a go. I'm going to put up a statement. And again, in the chat, could you please put in whether you think this is always true, sometimes true, or never true? And perhaps justify why. So here's your think time. When you multiply by 10, you add a 0 to the number. Do you think that is always true, sometimes true, or never true? Write in the chat your thought and justify your thinking. Now, what I would be doing in the classroom is getting the children to do turning and talk and discuss and share with their partner, or maybe again into a group of 4, so that you can bring back a collective idea about the statement. So I would like to think that this is not true. I'd like to consider this is really never true, because when you do 3 times 10, it's 30. It looks like we've added a 0, but obviously, really what's happening isn't just adding a 0. When you have 4.5 times 10, the answer is not 4.50. So let's think about how we would refine that statement to make it always true. And I think this is a better refinement. When you multiply by 10, the digits move 1 place to the left and 0 is added as a placeholder. Then I think that would make that statement true. You can get those statements, always, sometimes, and never statements. Enrich have a lot of them. I've included on the slide that you'll get when you get the resource a whole heap of collated statements. But where you get them from are really from what you see the children doing. When you see those misconceptions come up in the classroom, they are great opportunities to think, okay, I might not address this right now. I'm going to use that tomorrow as our starter in the class, so we can discuss those kind of misconceptions. They're very, very important, powerful learning opportunities. And the last one, which stems off this idea about considering whether things are true or false, is two truths and a lie. A popular party game, but this one is with a maths focus. Two ways that you could do it. You could pose up a picture or an equations or so on, and get them to create two true statements and a lie based on this picture. So if you were having to do that task now, can you think about two true statements that you can see or a lie? Or alternatively, you could just pose the two true statements and a lie, and the children have to decide which ones are true and which one is the lie. So in this example here, have you identified which statement, is it A, B or C, is the lie, and which ones are true? And if you look at this example, we can see, I think our lie, which one is our lie? 3 circles less than half full, well that's true. 2 circles are more than half full, I think that's the lie, but I've got one that's more than half full, which is this one here. Because see, there are a total of 2.5 full orange circles. So that's two truths and a lie. So hopefully that's given you some extra suggestions and some ways that you can use games and number sense routines as those whole class starters, or again how they can be used as part of an independent program or as part of home learning as well. So the link to resources is here. That will take you to the collection of maths games and the collection of number sense routines, and also a copy will be put onto the AMA website along with a recording of this presentation. So hopefully you've had a bit of fun, you've learnt some extra games that you can use to play in your classroom, and hopefully look forward to seeing you all again sometime. So I'll hand you back over to you, Robin, if you want to unmute yourself. I think she's coming. All right, well, I'll just have a look at what is coming up next. Hey, Robin.
Had trouble unmuting myself and getting the things off the screen to see. So yes, thank you, Marie. As always, a wonderful session with lots of great ideas, and the way you present those ideas is always creative and it makes us always want more. So fabulous for that. Thinking about, yeah, what's next for the AMA. We've had such a great response to this online thing. We're going to keep trying and keep going with it for a while. And we're shifting between now and the middle of next term. We're going to shift to a Wednesday or a Thursday evening. And you'll see there on this slide that on the 30th of July, Marie's going to run a session, getting ready for Maths Week, pitched at years 0 to 8. And on the 1st of July, which is the last week of this term, Alana Madgwick, who some of you might know, and I are going to weave together, for want of a better word, maths and literacy, and how that sort of goes together to actually build a common language for students all the way from 0 to 13. The next 2 spots we have yet to confirm, but there will be something in there. And then maybe next term we'll also do another Saturday morning online. So for those of you that are in Auckland, and MathX is definitely going to take place in some way, shape or form. If it's at the Barfoot and Thompson Stadium, we will be limited probably to teachers from Auckland, but if we do an online version, we'll probably make it open to any school that wants to be part of that. And for people who are in Auckland, the AMA is their AGM coming up in August, and again all those details will get posted on the website, for which you can see the link just there, aucklandmaths.org.nz. Next slide, Marie. And then for feedback, we'd love you to give us some feedback on what went well, how we could improve, because we've literally built this plane as we've been flying it. And so far it seems like it's gone okay, but we've all learned things along the way. We'll send this, is sitting here now, but we will also send it to you in an email.